In this video, we're just going to have a look at a whole bunch of examples of using the normal distribution to approximate the binomial distribution. Let's take a look. Okay, so this question says, the random variable w has the following distribution. W is binomially distributed, there's 300 trials, and p is 0.53. So does that pass our couple of little tests? Definitely, because n is nice and big, much bigger than 50, and p is really close to half. Okay, using a suitable approximation, there we are being told to do an approximation, find the probability that w is less than 150. So first step is to form the normal distribution, a normal distribution which has the same mean and variance as this, because that's the one that's going to look the same. Okay, so what is its mean? Well, the mean is going to be n times p, which is 300 times 0.53. And n, so 300 times 0.53 is 159. So 159 is our mean of our normal distribution, and our variance is n p 1 minus p. So that is 300 times 0.53 times 1 minus 0.53, which is 0.47. So I just multiply all that up, and I get a variance of 74.73. So now I've got my normal distribution. I just always use just a different letter to your original one, because it's w which has the binomial, so it's something else which has my normal. So I'll just use x since we haven't got an x yet. So normal distribution, and it's got a mean of 159 and a variance of 74.73. Now we need to do our continuity correction. So remember what that is. That is where we say, okay, it was less than 150. So, and I won't do the bars every time, but I will do the bars this time. It means if it was less than 300, let's say this one's 298. No, not 300. It's 150. This one was 148. This one was 149. This one was 150, this one was 151, and so on. If it's less than 150, then we only want these ones, that one, and then all the ones to the left. Now, where am I cutting through? Well, 149 is in the middle of the 149 bar, so I need to nudge up to 149.5. The other way of doing this is just write out a few numbers around your target number and say it was less than 150. So it's going to be these ones which I want. So I've chopped through at 149. So that's where, 149.5. So that is where I cut off at my normal distribution. So what I can say then is that the probability that w is less than 150 is approximately the same as, a very good approximation as well, as the probability that x is less than 149.5. So to solve this, let's draw our sketch. And we have a normal distribution with a mean of 159. And we're looking for the probability that x is less than 149.5. So let's standardize then to find the z value for this. So z is going to be equal to 149.5 minus 159 divided by the standard deviation, which is the square root of the variance. So the square root of 74.73, which is minus 1.0989. So I can then just say that's the same as the probability of z being less than that z value. And then I can just solve this, and let's use the calculator for that. So unbounded at the bottom end, minus 1.0989 at the top end, standard deviation of 1, mean of 0, and there's our answer. 0.1359 or 13.6%. Now remember that you can actually check these answers if you have the same calculator as me, because this answer of 13.6 should be very similar to the answer to the original question. So on this calculator, remember, you can go to distributions and you can select the binomial cumulative distribution. And we can actually just say, what's the probability of x being anything up to, well, it's up to 149, because it's less than 150. We had 300 trials, and the probability is 0.53. So this should be very close to 13.6. And it is very, very close. So that's a way you can actually just run a little check at the end of answering these questions. All right, let's keep going. In a large college, 58% of students are female and 42% are male. A random sample of 100 students is chosen from the college. Using a suitable approximation, find the probability that more than half of the sample are female. All right, so what do we know? Well, we've got if it's a sample of 100, then my distribution, well, let's actually use F for female, since we're counting how many of them are female, is going to be, so the number of females in my sample will be binomial. I've got 100 students I've picked from, and I know that 58%, so 0.58 of them is the probability that each one is female. So what's my suitable approximation? Well, I'm going to need a normal distribution. Oh, and the reason why it makes sense is 100 is nice and big and 0.58 is nice and close to a half. So my mean is going to be NP, which is 100 times 0.58, which I can do in my head. It's 58. And my variance is NP1 minus P. By the way, some people call 1 minus P the probability of failure. Some people like Q, so you sometimes see that written as NPQ. I prefer to just keep my variables to a minimum. So it's 100 times 0.58 times 1 minus 0.58, 0.42. And this I can't do in my head. 0.58 times 0.42, and this is 24.36. All right. So that means that the normal distribution, which I'm going to call X, which looks a lot like F, is a mean of 58 and a variance of 24.36. Now, we need to think carefully about the actual question here. It's saying, find the probability that more than half. Well, half would be 50. So what we're looking for is the probability that the number of females is more than 50, more than half. So can we approximate that using normal? Sure, we can. We just need to think, if it's more than 50, well, I'll write out a few numbers here. So 48, 49, 50, 51, 52. If it's more than 50, then it's any one of these. So where have I cut through? I've cut through at 50.5. So when I do my continuity correction, it's 50.5, which is the key value, not 50. So this is approximately the same as the probability that X, my normal approximation, is greater than 50.5. And it would make no difference, remember, because it's a normal distribution. If I put greater than or equal to, it doesn't affect it. It does here. That matters. We actually took into account this was more than 50, not more than or equal to, but it doesn't matter here. And let's solve this now. So we've got our normal distribution, which has a mean of 58, and we want the probability of X being greater than 50.5. So that's, let's say, here. So we can find the Z value by standardizing. 50.5 minus 58 divided by the standard deviation, which is the square root of the variance. 24.36, and that's minus 1.5196. So we want the probability of Z being greater in this case than minus 1.5196. Now here's where we need to, well, if we're using tables, we would need to use symmetry. Remember, if you're using tables, you would have to use the fact that greater than minus 1.5196 1.5196 is the same as less than positive 1.5196. On the calculator, we actually don't need to do that. On the calculator, it's enough to just go to normal CD and say we have a lower bound of minus 1.5196, an unbounded upper, sigma 1, mu 0, and we get 0.936.